Welcome to the Learning Video Series Extending Map Suite. This is Lesson 2, and we're going to cover how you can create your own custom styles. My name is David Rehagen, and it's my pleasure to present to you today. We're going to start by answering the following questions. Why create custom styles? What are the important classes? What is required for a custom style? And what overloads are recommended? Next, we're going to move on to looking at some code and showing you some various looks of custom styles. The first one is a simple style. The second is a decision-based style. And the third is we're going to show you how you can bolt on some caching to your styles. After the presentation, I'll be around to answer any questions that you might have or comments. So why create a custom style? The first is that you can encapsulate custom logic. You can make your features look differently based on things such as time, the scale that you're in, or other values that you might have. You can also tweak our existing styles. We have a whole bunch of styles that ship with the product, and there might be one that you like, but you want to make a slight variation of it. You can do that by creating your own custom style. You can also integrate external data at runtime and also do caching by creating your own custom style. This is really handy in a case where you might be using some information to decide how to draw your style, but the information is coming from a SQL database, and the overhead of connecting to that in real time might be relatively high. So you can actually bolt on a cache, fetch your data beforehand, and cache that in the style, so you get improved performance at runtime. Another great reason is for compositing existing styles. You might have two styles that you want to use in combination. An example of this might be the MasterCard logo. If you can imagine it, it's two circles that are partially overlapping each other. That's a great example of a composite style. What are the important classes that we're going to be dealing with? The first is the GeoPen and GeoBrush, and these are actually used to draw on the GeoCanvas, which is going to be passed into your style. They're very similar to the GDI Plus pens and brushes, but they're just a higher level abstraction of them. The next is the style itself. The style is an abstract class that we're going to be inheriting from, and its main purpose is to provide the drawing API so that you pass features into this style, and it's going to be your responsibility to draw them on the GeoCanvas. Styles take on a couple of different forms. One can be a decision-based style, and these are styles that don't necessarily do the drawing in their logic, but they proxy the drawing off to another style that they encapsulate. And a good example of this would be a value-based style. In a value-based style, you have a series of values, and each value has an associated style with it. So if a particular column in the database is 1, then you want style A to be drawn. If the value is 2, then you want style B to be drawn. The next type is the GeoCanvas. The GeoCanvas is a geographic drawing system. It provides APIs very similar to that of GDI+, but one important distinction is that it doesn't draw in string coordinates, it draws in geographic coordinates. So you're going to be able to pass features into the GeoCanvas, tell it what pens and brushes to use, and it's going to use that to draw. So we save you all of the time and expertise from going from world coordinates, which is what the features are in, to screen coordinates, which are what you typically use to draw, on the screen or onto a bitmap. What are the required overrides for a style? Styles are fairly simple objects, and luckily it only has one method that absolutely has to be implemented when you inherit from it. And this is the draw core. And the main function of the draw core is to do the drawing for the style. You're responsible for taking the feature that's passed into you and drawing it on the GeoCanvas. One important thing that a lot of people overlook is that you can create a style that almost does no drawing at all and actually proxies its drawing off to another style. So you can imagine that you have your own custom style that gets a feature passed into it, and instead of your feature doing the drawing directly, it actually creates a number of styles internally to composite the drawing. And in this case, you're really offloading your drawing to other styles. And this could be based on business logic or as I mentioned before, to actually composite styles together. An important caveat is that while this is the only required override that you have to use, there's a number of other overrides that are going to be very useful to you if you need data from an external source, for example, or you want to provide a nice handy method of someone getting an image for a legend to represent your style. So what overloads are recommended? The first is get required column names core. And this provides a way that you can communicate to the rest of the framework what data columns you need to render your style. It's often the case that there's a piece of data that's associated with your feature that based on that data, you're going to decide to draw the style one way or another. So you might change the color of a style based on the value in the database. Well, what happens is that when your style goes to draw, it's going to need to communicate up front that it needs that data from the database. And so this method is going to provide you the means to communicate that back out. Note that if you're using a composite style, you'll also need to query your children as well. And this situation comes up in the example of a value style, where the value style is really a collection of a whole bunch of styles that could be drawn, but you're doing some data comparison to see which one it'll actually be. Well, each of the different styles that could be drawn are first-class citizens in their own right, and they might need data. So it's going to be your responsibility if you have children's styles that you query them to find out what they need and then pass that along the chain. Next is the draw sample core, and it provides a sample image that can be used to create a legend. So you would override this so you can pass back a representative sample of what your style looks like. And just to note, in some complex styles, it may be difficult to provide this functionality because there's literally an infinite number of looks that you could potentially give to a style, and it might be hard to encapsulate that in just one still image. So let's talk about the sample code that we're going to be reviewing today. The first is a sample on how we can draw different point sizes based on data from the feature. And in this particular case, what we're going to do is that we're going to take the world capitals and we're going to look at their population, and depending on their population and a factor that we set, we're going to draw those capitals as a circle of varying sizes. Now, you can get almost the same effect by using a value style or a class break style. However, the difference is that a value style and a class break style are very coarse-grained. I mean, inside of a class break style, you might have 5 class breaks or 10 class breaks, but you wouldn't want to have 1,000. But if we create our own custom style with this factor, then we can have points of almost infinite sizes. So it's very flexible. The second sample shows how we can choose different styles based on time information in the feature. And what we're going to do in this sample is we're going to take the world capitals again, and we're going to look at their time zone. We're also going to look at the local time on our system. And if the time in those particular capitals right now is at night, we're going to render them with one particular style. And if it's during the daytime, we're going to render them with a different style. This is a great way to show the flexibility of using time to adjust the way that different styles look. The third example shows how we can cache pre-known values to increase the speed of an existing value style. And what we're going to do in this sample is we're going to take the value style and we're going to bolt a little cache onto it. And what it's going to display is the world capitals again with different styles based on their population rank, but that population rank is going to be cached. And what this is going to do is it's going to increase performance slightly because when the feature gets requested, it's not going to need to go out and query the DBF every time it's rendered. A lot of our customers are using this kind of thing for caching values that come from an external database, like a SQL database, where they can take the hit of making the SQL call up front when the program starts, and then every iterative redraw, the data is cached and it's hot waiting for them. There's also an example of this in the developers blog area. I believe it's called a cached value style. So you might want to check that out.